Let's do this. So we're part one of our lesson today is we're going to be verifying solutions. We talked about solving equations like this with an equal sign, and now we're going to have an unequal sign, an inequality. How do you verify it? How do you know if 4 is a possible solution? This comes up in my Algebra 2 trig class all the time. I want to make sure you understand what it is we're talking about. Is 4 a solution? Here's what you do. You just plug it in. Let's plug it into the equation and see if it will work. And by work, I mean, let's see if it will make the equation a true statement. We're going to plug 4 in right where that x is. And please put parentheses. Neatness and organization is so important here. And that's not just because I'm a neat freak. What's 2 times 4? We're going to talk about reading this symbol now. 8 plus 1 is 9. How do we read that symbol? How do we read this? This is actually a math sentence. Very nice, Jess. Yeah, it's either less than or equal to or greater than or equal to. And how do you decide? I always thought of it in terms of Pac-Man. Do you see the Pac-Man wanting to eat the bigger quantity? So you will have to be able to write a sentence to describe that. So 9 is greater than or equal to 3. And that little bar on the bottom, that's where we get that equal to part. Now, is that true or is that false? 9 is greater than or equal to 3. It's definitely true. It's definitely true. Yep. That's a big check. And so, yes, x equals 4 is a solution. Because it's true. It's a true statement. All right, so let's play again. Let's play again. Right? I'm telling you k equals -2, and I gave you an equation. What do? How do we check to see if it's a solution? We plug it in, plug it in. You know what I'm saying? Nah. You never saw that commercial for Glade plugins? Plug it in, plug it in. Yeah. Come on. Let's do this. Let's plug it in. What are we going to do? Plug it in, plug it in. You know what I'm saying? No? No? Ah, whatever. You guys are lame. You guys are too quiet this morning. It's Monday, though. I'd appreciate that. Oh, what happened? Oh, no. Can't have that. It's Monday and your grades? Kind of killed you there. So, yeah, they do plan it like that. So, yeah. So, guys, let's do this. Let's do this. Right? You have a 9. Let's take care of this side. What do we learn about? What is that? You've got a -4, and then in parentheses, you've got a -2. What do we do to those? Multiply. So that's going to be a +8. This is going to be a -6. Okay, -5. Now, what's 9 plus 8? Yeah, man. 17. 17. And what's -6 minus 5? You know what most people said the answer in my other class was? That's what the most common mistake for that is.
1.
Yeah. Yeah. It's -11. Now, let's read that before we get on to deciding whether it's true or false. How does that even read? Very good. Is less than or equal to. Now, what are you thinking? Does that make any sense? Is that true or false?
True. No, it's false.
Very nice. Yeah, it's totally false. There's no way. That makes no damn sense. So, no, right? K equals -2 is not a solution. How easy. Wish I had my Staples button. You know what I'm saying? That was easy. So now we're up to solving equations, right? Solving them. You don't know what the answers are. We're trying to find all the possible ones. What do you do? If there was an equal sign, what would you do, man? Yeah, let's plus 8 to each side. Let's try and get that x by itself. Good job. Good job. Way to go. So we got x is less than 31. And let's write that down in words. X is less than 31. Is this the same problem? Attention to detail, right? Let's take a look at the two right next to each other. They're kind of flipped. Something very special happens in this one that I wanted to show you. Yeah, that's the first thing. We do have to subtract. What's 23 minus 8? Okay. So now we got negative x is less than 15. Okay. And that negative x, by the way, that's the same thing as me saying negative 1x because, there's a 1 in front always. Now, there's a special rule with these, and this is the only real big thing different that we're going to do. Does anybody know the rule with these symbols? Tatiana. We're trying to get x by itself. So how would you get x by itself? What would you do? Yeah, we're going to divide because these two are stuck together with multiplication. To undo that kind of glue, we need division. So you divide, and we have x, flip the symbol, is greater than negative 15. And that's crazy. Let's write that down. That's the special thing that you guys need to remember about today. Remember, right? Remember to flip the inequality symbol when you divide by a negative number. So when you divide by a negative number, the symbol has to flip around. You are a brilliant girl. You are brilliant. You know what Sulema said? She said we have to distribute. I gave this a funny name. What did I say it was also? Make it rain. But on your test, sometimes they ask you like, okay, what kind of property would you use? You use distributive. Now, what happens when you distribute? You make it rain. What are we doing? We are multiplying. So 3 times 3x is 9x, and 3 times negative 2 is negative 6. Okay. Now, people got all messed up here. I remember on their tests. There's nothing really to combine like terms that are on separate sides of that symbol, that are on the same side of the symbol, but these are on separate. Sulema, help us out again. Shoot. You are so smart, Sulema. Yeah, you do need to get x's on one side, and we need to get number. Okay. Combine like terms for me means like on one side of the equality or inequality symbol. And that's what people did on their tests. And that's why they lost a point or so. Because to move about this symbol, let me put a border. You could think of it as there being a border. To move across that border, what do you have to do? Sulema? Yeah, you have to do like the opposite of the operation going on. So, let me erase my border for a second. Let me erase my border. Now, how could we get all the x's together? How could we get all the numbers together? I suppose that's combining like terms, if you want to think of it. But not really, because we're on opposite sides of the symbol. What do you think, Jess? How can we get these x's together? Add them, but they're on opposite sides of the symbol. So you subtract. You could also think of it as like kind of like a weight, right? Both sides are the same. So I'm going to subtract 7x from both sides. That's what I'm going to do. No. In all the problems, though, if they're on opposite sides of the inequality or equality symbol, you have to do the opposite operation in order to combine them. If they're on the same side, like let me give you an example. Suppose you have 3x plus 2x equals 6, right? Then this is combining like terms. Combine them, they're on the same side of this symbol. You get 5x equals 6. But suppose now that you have 3x equals 2x plus 6. You see how the 2x is on the other side. You cannot just combine them. You have to subtract 2x from each side, and then they eliminate. You get like 1x equals 6. And so that's the difference between the two different scenarios you need to keep track in your mind. Yeah. You could, that's something that's really doesn't make a big difference. At the end of the day, if you subtracted the bigger number, then we'd just be dividing by -1. Doesn't matter which one, but this makes a difference. Same side, combine, opposite sides do the opposite operation. That was a really great. Okay, now let's do this. What do we do next? Yeah. You know what -26 plus 6 is? -20. And now what do you do? What do we have to do to get x by itself? Divide by 2. Are we flipping the symbol? No, because we're dividing by a positive number. So the answer is just that. This. Let's see if we can try and read that. How does that read? Alexis. Yeah, -10 is greater than x. Very good. Really, great job. Let's talk. Is this the same thing as this? Why? Because we rotated it around? Absolutely. You could say that too. It means the same thing as -10 being greater than x. Yep. You're all good. Yeah, so be able to recognize this on your sheet. And with that, let me give you your homework so you can start it. Oh, damn, right? Damn, we got 6 problems. Damn, 5 of them are multiple choice. Damn. But you cannot, you have to show your work. You must show your work. I don't care if it's multiple choice. Not on this one. I got the answer sheet.